Hello, everybody, and welcome to this week's workshop with the University of Ethereum. I'm here with an incredible guest, Matheus Pagani, and really excited to dive into the workshop today. This is really building on the introduction to blockchain fundamentals that Matheus did with us a few weeks back. And, we're just going to be building on that and going deeper into Solidity today. So without further ado, I'm going to pass it off to you, Matheus. And again, so happy that you're here. Really loved our Twitter space with Biddle Giddle. Grateful for you showing up for us and being so supportive.
Thanks a lot for this space, Rachel. Thanks for all of you watching as well, following along. I hope that this workshop is going to bring you a little closer to building on Ethereum, put your hands on into blockchain development. Because last lesson, we saw a lot of the fundamentals. I gave you a lot of little building blocks, but now let's start to put them in order so you can build something with it. You can have some outputs. So let's begin with some practical tools. The first one that I would love to introduce you is Etherscan, a way for us to scan what is happening inside the Ethereum blockchain, all of those blocks, all of those transactions. And here I'm connecting with a special version of Etherscan that is connected to a testnet, called Sepolia testnet. It's going to be super useful for us to learn how to build on blockchain, how to use this technology, because in a testnet, instead of having to pay for acquiring the tokens, instead of having to pay like real money to acquire ETH in mainnet, in a testnet you can get those tokens to transact here for free. They are like sandbox environment token that you can ask from places like Faucet, you can ask from people in the ecosystem because they are for free. You can get them without working for it. Of course, because of that, these networks are less secure, but they are great for the students like us to explore the blockchain, explore the functionalities, since this testnet is made to mimic how a mainnet, how a normal production environment would work. For the same things that we would do in a testnet, they would work almost the same in the mainnet in most situations. So this is Etherscan, where we can interact with this application, searching for address, for blocks, for hashes and all. And I would love to start interacting with it using a friendly version, a friendly tool of the wallets that are those accounts that we mentioned in the last workshop. Because the unfriendly way, the protocol way, is for you to process this yourself. You would have a script, or you would do that in paper by signing your transaction, by doing all of this math yourself and publishing to the network. Thanks God that we have those tools to do that. This tool is called wallet. So whenever you wrap your head, what is a wallet? That's too complex. I need to install something else in my computer. No, this is actually making your life much, much easier. Okay, this is for enhancing user experience. This is not detrimental to the user experience, because this little application that I have, this little extension that I have installed in my browser called MetaMask web wallet, can abstract all of this work for me of signing those transactions for them to appear here in the network, for me to see them into the Etherscan, Sepolia testnet exporter version of Etherscan here. That is making a simple action button click here of send by providing some information, by filling a little small form of dialogue with this application. I can broadcast this transaction to the network. Simple like that. If you remember from last workshop, when I was explaining the fundamentals, we saw that the entirety of the state of the blockchain can be determined by all the transactions that came in place from the genesis to now. So for changing the state of the blockchain, I would need to send a transaction. For this transaction to be valid, let's see if you remember that part, it needs to comply to some requirements. One of the requirements is that the signer signing for that transaction, the person's broadcasting that transaction would sign to pay for that transaction, pay the transaction cost, the gas, and this transaction need to be valid, cannot be forfeit, cannot be falsified, right? This is a super complex process to do manually. So I have this wallet here to save my life. I do need to install it. I would need to go for metamask.io, install that in my browser. After I install it, it's going to show in this little pane. And this is an improvement of user experience. There is no way to use a blockchain without signing those transactions. The easiest way for us to sign transactions is with a wallet, right? So finally, let's do this. Let me send a transaction. For example, Rachel, would you have one address here for me to use an example for sending you some assets in that network?
Absolutely. Yep. I'm ready over here.
Rachel has sent me
Okay.
her address for me to use in this test transaction. You are going to get in tax trouble, right, Rachel? Receiving money here live, can't deny it now. Just kidding, people. It's testnet money, has no legal implications whatsoever, at least yet. So I'm going to click on this simple button, send. I'm going to fill this form, this little dialogue here with the address of Rachel's address, and I'm going to send some assets that I have in my possession. Those testnet assets that are not worth anything at all, at least not in Sepolia. A huge sum of money of 0.001 Sepolia ETH. Okay, Rachel.
Awesome. I'm rich.
Going to be super rich. And this is going to, when I click next here, this is going to prepare this transaction to be signed with my private key stored inside that wallet. It is stored in my browser, in my device. No one can have access to it. And by signing this transaction and publishing it to the network, when it's included in a block, this transaction, it is sent. I have here the status as pending. I can view it in the Block Explorer. This is the Block Explorer view for that transaction. It has a state of pending. And when this is included in the blockchain, this is going to create a state change in the blockchain. This is exactly the same talk we did in the past workshop. But now we are viewing. Rachel is going to fill that in her assets, in her owned assets are going to update after this transaction is included in a block.
Yeah, I think I see it, Matheus, in my wallet. So I'll go ahead and share my screen and show everybody here. One sec.
Let's see. I'm not fooling anyone. We can see that for real.
Here we go. There it is. Can you see my screen?
Yeah. Oh, you are very rich now. 0.001 Sepolia ETH.
Rich 0.001 Sepolia ETH.
And what a cool website you have in the background.
Awesome.
So this went through. We completed that transaction. We signed this. If we click here, it is in more detail. We are going to see all of the little details of that transaction. We did pay some gas here. It went from my account. So 0.001 ETH went straight to Rachel's account. Also, I paid this fee. Some amount of it was burned, some amount was minted, some amount was sent for the miner. All of these mechanics of gas, they were changed a bit since we had the update in the 1559, in the EIP 1559. So it's not a super simple math, but it's simple math yet. And this causes this transaction that we are here viewing, this is the overview, this causes a state change. Just as I said, I would have one person, my address, paying 0.01 plus some fees. Rachel's address is going to receive 0.01, And there is a block producer, formerly called miner, that would receive 0.0000315. It is a little different because of the EIP 1559. Just mentioned that this introduced a little math changes to the mechanics of the fees. So there is a little difference between what is received for the miner and what I pay because of these mechanics of fees being burned and rewards being minted in some occasions because of this EAP. But if you disregard that, you can consider that as a rounding error or whatever. Consider whatever makes it easier for you to understand it now. The important part is that the transaction went through. It was included in the blockchain, and now no one in the blockchain can claim that Rachel is not entitled to this 0.001 ETH. Everyone can agree with that. They have consensus over that. Okay? This is a practical explanation of all of those fundamental concepts that we had about the blockchain state, about this transition between those states. And this is called a blockchain because this transaction was included in a block together with a lot of other transactions. And after this block, we have this unquestionable, this ultimate, undisputed state where Rachel has this 0.001 ETH more. Okay. We could stop there to understand the blockchain part, but for this workshop today, I want to go a little further. This is what a blockchain can do for managing assets transactions, for managing the ownership over assets. The ownership over assets is a form of data, it's a form of information. It is a number. I am inside my possession holding that amount of assets. I have 3 apples, 5 bananas, this kind of basic math, but is one instance of information. It is data that is being manipulated there. This is what, for example, Bitcoin was doing much before Ethereum. Many other implementations of blockchains could do that even before Ethereum. The big difference, the big news that was introduced by Vitalik, Gavin Wood, Joe Lubin, and everyone that came up with Ethereum, even before that, it would be a proposal of a change for Bitcoin, but the Bitcoin community wasn't very friendly for that at the time. So it became a new project called Ethereum. The big change is that what if we could change all the data as well? We are changing here, with this example with Rachel, we are changing just the balance, one kind of information. This state changed the balance of an asset called ETH here. It was 0, increase it to that. It was 2.6, decrease it to that. It was 9,000 something, increase it to that. This is information being changed about balances. But what if I can change all the kind of information? Like my high score in a game, like my voting power, the votes in a ballot, the results of a lottery, the votes in a DAO, or whatever kind of information that you would like to process inside an application. What if we would process this inside a blockchain? Sounds like a crazy idea. Look, if we use Etherscan to see all transactions, this is a list. Let's see if I can increase the zoom for it to be more readable. This is a list of all recent transactions in the Sepolia testnet. We are going to see some transactions with 0 value. 0 value here, 0 value here, 0 value here, here. If we understand blockchain just as transaction of assets, like this transaction I did for Rachel, it wouldn't make much sense to send 0 ETH, right? I'm using the network for sending a 0 money transaction. What I'm doing, I'm sending a message for someone else. I'm spamming the network. What is happening here? So these 0 value transactions, for example, this last one here, this first one here. It is invoking this thing called contract for making a contract execution, a function execution. If we click here on more detail, this is a random transaction that I found in the network. I'm going to see that in this transaction, I'm passing some data on that. Whomever sent that transaction, they are sending some data for this smart contract. This data could be an encrypted message, could a spy network communicating through countries. Yes, that's possible. Or it could be just some parameters, some text, some whatever they are sending here, that when executed inside a smart contract, a special account is not an externally owned account like Rachel's address. It is a special kind of account that is a smart contract that can hold code. It can not only change not only it's going to change the assets, because whomever sent the transaction is paying some gas. That's always going to happen. Whenever a transaction is included in the blockchain, you're going to pay for the processing of it. So you have two state changes here. One person losing the assets spent for paying gas, and the other person, the block producing, receiving it. That's always going to be present. But we have a third state change here in something that is a smart contract, and we have some updates of a storage address. This is a random smart contract that I found in this scan. And here we are updating a number from 353 to 354. I don't have any clue or any idea of what is happening in that smart contract. But yes, we do have this little program, this little memory being updated. That could be a game. That could be like my number of attempts. I went from 353 to 354. This could be the number of votes. This could be whatever happening here. We could have like someone sending, this is a text, this is a number. I don't know. I don't have a clue of what this smart contract is processing here. But it seems that it is increasing some things. It is increasing some numbers from 0 to this number, to this number, and this. This, people, is not a balance of an asset. This is not necessarily financial things. This is a program being executed. This could be a Tetris game. This could be a lottery. This could be whatever. This was the big change from just how Bitcoin operated, just how you would manage assets, to now that you can manage any kind of data. You can manage assets, that is a form of data, but you can manage any other things. You can manage the state of a game, whatever you want to make inside as an application, living inside the blockchain. So this is possible because we have in Ethereum and in some other blockchains, this figure of a smart contract. Again, this is a random smart contract that I found. That is a special kind of address living in the blockchain. That these addresses, they don't have a private key. They are not governed by a private key. There's no person behind it. Is it an AI? No, it's not an AI. It's just a piece of a program that has all of those bytes there stored in that address. You have this included in the blockchain, forever, permanent, inside this address. And those little bits of data, those little tiny pieces, those numbers and letters, hexadecimal characters, those are little program execution instructions that are living on chain that are able to be triggered. What triggered the execution of this code is something called EVM, the Ethereum virtual machine. That is like a program that you can feed data to it, that you can feed instructions to it, and it's going to process an output. For example, this output that we have here, this was the product of interacting the call data that we have here, this call data, with the content of the smart contract inside the EVM. Call data plus bytecode inside the EVM equals to state change, like this, possibly state change. It could be an error, it could be nothing. This is the concept. This is what is happening the machine level, in the under the hood level. But what if I told that you can do that super easily without brushing off those bytes, those zeros and ones? This is possible because people invented smart contract coding languages. So instead of coding it in those hexadecimals that you would need to understand each opcode, machine language, and all, instead of doing that, you could use a programming language called Solidity, for example. This programming language is designed for building smart contracts, a piece of programs, to target the execution of the Ethereum virtual machine. To target it high level, like variables, functions, strings, definitions, that you could abstract away a lot of the things happening low level in the EVM and still program a piece of code that is a usable application for you to run on chain. That's the idea of Solidity. There are many other smart contract languages that you can find out there for you to build your smart contract. It doesn't mean that the Solidity is going to be included in the blockchain, okay? That's very important. Whenever we deploy a smart contract, it needs to be in this form of bytes, okay? Hexadecimal characters representing those bytes here in this application, but actually what we deploy are the byte itself. Solidity, whenever we code the Solidity code, it is not 100% translatable instantly for bytes. You would need to have a middleman that is called a compiler. So this language is designed to operate in a compiler for the compiler to build the bytecode for you. Okay, some high-level instructions that written in Solidity made for operating the compiler, that the compiler then can build this bytecode for you so that you can push it into the blockchain. For that, for us to code this Solidity file in the way that you need to be coded, we are going to make use of an IDE, a developer environment that is able to be run in the browser. So if you don't have a computer with Node installed, with Python installed, whatever you might want to use for your development needs, you can have just a browser, open this website, remix.ethereum. I had it open here, but we close the other one then. And this is going to guide you through creating your smart contracts and interacting with them. Everything that you find here as instructions for using Solidity can be implemented inside Remix, because you have here a file explorer capable of creating new files. You would create those files inside folder just for it to be organized, but nothing stops you creating something in the hood here. Let me increase the zoom a little more as well. Okay, so this Remix. And for it to be compilable, Solidity has some rules. Has those specifications, language specifications that we're going to see today, overview. If you are coming here like with AI mindset first, if you entered software development with AI in mind, you would expect it to be something like this, like my contract.sol, and then you code it something like this. I want to build a contract to play Tetris on chain. Okay, but that's not Solidity. That's not possible yet. You could ask an AI to write Solidity for you, yes, but This is not what programming language is going to do for you. No, you would need to learn those small building blocks, the semantics of it, the syntax, the grammar, for you to build a valid file. Okay, so this mycontract.sol is not a valid file. We delete it because we need to understand some of the syntax. But let's not forget our goal. Our goal is to understand this smart contract idea that we interacted. We saw a transaction interacting with a smart contract. And for it to happen, we need to have this bytecode deployed. For building the bytecode easily, we can use Solidity programming language. For writing Solidity, we can use an IDE like Remix. Okay, but it's not creating any kind of file. We would need to follow a structure. Okay, so a layout of a Solidity source file needs to follow a specific structure. Otherwise, it's not going to work. I can't start typing just anything I want. This structure is composed of a license identifier to specify what kind of license you want your smart contract to be covered for, like software development license or software use license, and the version pragma definition to specify what is the version of the Solidity compiler, that program, that middleman, remember, is able to be used for compiling your smart contract to bytecode. This is the requirement for it to be a valid Solidity source file. And if you open Remix there on your browser, open this contracts folder, and open any of those example contracts here, for example, storage, this first smart contract that we have here, storage, you are going to find in the beginning of it, in the first lines, you're going to find those two things exactly as specified in the documentation. The license identifier, saying that this contract is written at GPL3. So all the warranties, all of the copyrights, all of the liabilities, and all that, they are governed by whatever GLP3 says here. Not super important for you to start developing, but it is good to review this subject later whenever you're going to deploy something on chain or publish your smart contracts later. And the Pragma Solidity version, stating that this source file should be compiled, cannot be compiled actually with anything outside of this range. It should be compiled with things from 0.8.2, including that specific version can be used, or anything in between 0.8.2 to 0.9.0, excluding. So if I try to compile that with 0.9, for example, error. If I try to compile with 0.7, error. If I try to compile with 0.8.1, error. Okay, this is designed to prevent some kind of errors, some kind of mismanaged results or wrong results that the compiler would get depending on the breaking versions of Solidity. Is that super important for me to begin using smart contracts? No, I'm just stating that out so you know why those lines are there and why you can't remove those. You would have warnings or errors depending on what you are trying to do here, okay? And this is enough for complying for it to be a valid Solidity file. If I delete those, I'm going to have problems when compiling and deploying that smart contract, okay? Also, I can have some comments, single line comments and multi-line comments, like those that we have here on line 5 to 9, 14 to 17, 22 to 25. Those are ignored by the compiler, okay? Those are only important for us we're going to read this smart contract. For the machine, for the deployed bytecode in the blockchain, those comments, they don't even appear in the bytecode, okay? They are ignored by the compiler when building the final bytecode. And this is the explanation of the layout of this example storage.sol. Owner.sol, same thing. The only difference is that now we have this import here. This import. I can import from all the file, all of the content for this file, just for organizing. Instead of have one huge file with everything, you would break it down in all the files, all the dependencies. So you have storage.sol with this structure, owner.sol with this structure, and ballot.sol, those three examples inside Remix with this structure. Okay. So yes, this is a valid source file for a Solidity written smart contract. Later, we have this code from line 10 to 29. This is following the syntax and the grammar for Solidity. If you want to know more about the structure of a contract, you would click on this part, structure of a contract. Try to get very familiar with the documentation, with the navigation, because instead of remember everything from this language, you could have this handbook. Like I'm writing a smart contract with the documentation on my side, opening another monitor or in another computer or in my cell phone. So it's very important that you know how to navigate to it. So if I want to understand the structure of a contract, this is the place. Inside a contract, I can have state variables, I can have functions, I can have function modifiers, events, and all of that. What are state variables? Are variables that are permanently stored in the contract storage. They are persistent on chain. This little definition here in line 12 means that whenever I deploy that smart contract, it is going to set aside a small place in the blockchain for us to keep track of the value of this variable. This is not common in software development, people. I don't know if you have built projects in other programming languages, in Java, in Python, in Go, whatever. Usually when you run a program and when you finish the execution of that program, all the variables, they are gone. They usually live in memory. Sometimes they got saved by, like, they remain in the garbage, but in most situations they are gone. You run the program again, you would start from zero. Like playing an old game. Imagine those old consoles, even before you have like memory cards. Every time you would start a game, you would start from zero. If you want to return from where you stopped, you would need to input a code, something like this, some symbols, some password to return to a specific stage of that game. Don't know if you are that old, but yes, in the 90s, when I was young, this was our experience. If you bought a magazine with all of the passwords, you would be able to start the game in the final boss. Yes, that was possible. Because this is the normal situation for programs. Whenever you shut them down, when you open them again, you don't have the variables. You don't have the memory state of the previous execution. You would start from zero. We would start from the starting situation of the program. Giving persistence, usually something that is programmed. Is something that you need to implement a database, you need to implement I/O, like writing to a file or something like this. So that is, using smart contracts in the blockchain, you have persistence, you have storage there, out of the box, just by creating this feature of state variables. Okay. So when we were seeing this state change happening here in that smart contract, that random smart contract that I found out in the web, we are seeing some variables. This variable at the storage address 4, the 5th variable, you have one in the storage address 0, we have one in the storage address 1, one in the storage address 2. If you count them up, this is the 5th variable. It was updated. This is another random variable, was updated. This is another random variable, it was updated as well. So those are state variables inside the smart contract. This is very simple to see here in the. This is something simple to overlook. We see it very simple here. In Solidity, it's just a variable of the type of a number called number that is going to be forever in the storage here because we created it here inside the contract. It is not inside a function. So this is a state variable, a very powerful feature for you to store things forever with persistence inside smart contracts, making programs here. The second one that we are going to cover today are the functions. There is no way to run a contract, execute a smart contract. Like you download that app in your phone and you open that app, or you download a program in your computer and you execute that computer. This is not possible with a smart contract. You have no single execution of it at all, like a main function, whatever. You can only execute single functions of it, like a vending machine of some sort, where you need to pick an option to interact with. You cannot run the whole storage smart contract here. No, those functions are like entry points. And if I create a smart contract with 1,000 lines of code without functions, like I could make errors, I could make program errors, program events, program state variables, program a lot of things. But if I don't make functions, there is no way to execute it. It's going to be like thousands of lines of code, useless, because the only way for me to execute the smart contract code is by creating functions. Those are the doors for me to interact with those smart contracts, the buttons in a vending machine. A smart contract without functions is a vending machine without buttons. You can't buy anything out of it. It's basically useless. So those two, the state variables and the functions are those two important building blocks for us to understand this simple smart contract. The file is conforming to the structure, like I mentioned, and now we have those two functionalities, the state variable, number, and those two functions. One called store that receives a number, and in the line 19, this function is programmed, is structured in a way that is going to override the value in the line 12 with whatever I'm receiving that function. So if I call this function with the number 5, it's going to pick this number 5 and store here inside this number forever. And you have this other function called retrieve that is going to do the opposite. It's going to pick whatever I have inside number and retrieve back for whomever is called. That is an important part of the documentation for us to understand with this. That is the language grammar. This is the map. This is the overlay of everything that every of those syntaxes that we're interacting with. For example, inside a contract, we have all of those contract body elements. For example, the state variable declaration that we saw, but also the function definitions. How to get there? You go for language grammar, then you go for contract definition. Inside the contract definition, this is the contract definition. You see, you have those contract body elements. So this is the flow for the contract body elements. You have function definition, and this is the flow for how you declare a function definition. Let me guide you through this flow as an example. You would always start with the word function. So yes, we started with the word function, exactly like that. I cannot put like a capital F. I cannot put in plural. It needs to be exactly character by character function. I can put an identifier, any name I want to pick, like function potato, function whatever. I just need to avoid reserved names. For example, function pragma. No, this is not possible. Function contract. No, this is not possible. Function return. You see, those reserved names, they are not allowed for me to use. Anything else, I can. This is why we have this identifier option. Then I would need to pass the parameter list, the amount of things I want to pass when invoking that function. In this example of the line 26, it is empty. But in this example of the line 18, it is a number. I need to pass one parameter of the kind number for it to be invoked. So this is the flow for reading. I go through this line. Whenever I hit something round, I need to put exactly as it is. Whenever it is a box, I can fill with something. Whenever I have those branching paths, fallback and receive, it is optional to go through that path or not. So I don't need to specify it as fallback or receive. Those are special kind of functions that I could use. Parameters list, it is skippable. It is possible to skip. You see, you have a path here. And then you have visibility, you have state mutability, modify invocation, virtual, and override specifier. Visibility and state mutability, they are needed. Visibility is non-negotiable. It's non-negotiable. You need to pick one of those: internal, external, private, or public. All of these four, they have different capabilities. You have public and public here, because those are functions that can be accessed from the outside. But later on, I'm going to show a way for you to debug and discover those other possibilities here in the grammar. The other thing that you need to specify is state mutability, but here we have one default, that is the non-payable. So it is possible to omit the state mutability, like we have here in the line 18. We have omitted the state mutability. It is possible. That's not possible with the visibility, but it is possible with the state mutability, because we have this default. Whenever I set something to pure, to view, or to payable, I am altering this default to this. A function that doesn't cost anything, like pure, and it can't view the state of the blockchain. A function that doesn't cost anything, that is the view, but it can access the state of the blockchain. A function that can change the state of the blockchain, but it costs, that is the non-payable. And a function that can change the state of the blockchain, costs, and is able to receive money, that is the payable. So you have those four branching options. Do you need to remember that now? No, I just introduce you to the things. What are those little words that we are seeing there? And I'm going to show you a way for debugging this, okay? So this explains how we build these functions. We are just following the grammar as needed. After we define visibility and state mutability, we would need to return something or not. See, it is optional. So this is why in the line 18, we have this function. It's not returning anything, but in line 26, it is returning something, okay? Half an hour, but it was fast, but it's more than enough for us to understand those 29 lines of code that we have in Solidity here. Let's see if you remember. It is possible to push that on-chain. Can I copy those lines and paste it on-chain for it to be a valid smart contract? The answer is no. I need to go through a program first, a middleman. That is the compiler. So whenever you enter in Remix, you're going to be in this pane, File Explorer. Then you can switch under this little magnifier here, this searching files. Under this, you have the Solidity compiler. Then you can just click on Compile, and you have the bytecode. Click there, you're going to have the bytecode. If you want to see the bytecode, you can click here on Copy. Then you can paste. So all of those hexadecimal characters here, they are part of this bytecode. Okay. Do you need to interact with the bytecode directly? No. The API, the application binary interface, can provide you easy ways for interaction with this bytecode through applications without your direct need to understand those opcodes or the binary code itself. But it's super useful because now you can copy this bytecode and include that in a transaction. I could do that manually with my wallet, but it's quite complex to send this specific transaction like this to create deploy a smart contract directly to a wallet. This is why this IDE can help us. It helped us to view that smart contract, to write a smart contract possibly, helped us to compile that smart contract. Now it's going to help us to deploy that smart contract to interact with my wallet to deploy that. Okay, so instead of sending this raw transaction directly, I could come here to this pane, deploy and run transactions. I could use this first option of environment to choose this specific option of injected provider that is going to connect to my MetaMask. Don't know if it's possible for you to see here. There's no way for me to zoom in, but I'm approving the connection in MetaMask with this account for Remix to say, hey, Remix, you are allowed to interact with it. Approve this connection. And I'm going to click in this orange button here called deploy. That is going to pick the bytecodes of storage.sol, that smart contract that we have here, and is going to pack it inside the transaction. And it's not going to send directly to the blockchain. No, it's going to ask my MetaMask. Here in the top right pane, I have the little pop-up from MetaMask asking me to confirm if I want to send that transaction or not. And if we look at the hexadecimal information, all of those bytes here, this is exactly the bytecode that we compiled. This Solidity compiler output ending 0033. Let's see. The hexadecimal ending in 0033. Exactly the same thing. See? This is going to be sent to the blockchain through a special kind of transaction that is a contra deployment transaction. Okay, starting with those specific bytes. And when I confirm this, this is going to send this transaction to the blockchain, signed with my address, my private key. I'm allowing to pay gas, allowing my address to give up to some amount of ETH for that transaction to be included. And when this transaction is included in the blockchain, it is going to create a new contract. It's going to give birth of a new entity living forever in the blockchain that is a new smart contract. Okay, it was included in this block 59.51.539. And as soon as this block is indexed, here I have that little smart contract there. Remember that I told that I would show an easy way to debug this smart contract? So whenever we deploy a smart contract, you can see down here in the bottom, those little buttons. You expand here, storage, you can see those little buttons here. For you to retrieve information from the smart contract, this retrieve function is marked as view. I mentioned that briefly. It is view, so it is free to call. I'm not paying gas. I don't need to approve that transaction, no, because it's for free. I'm not paying gas for calling it. And it can access the state of the blockchain. You can see what is the value of number stored there. And if I click in this orange button, if I click this now, it's not going to do anything because the function you store, it needs one parameter of a number. So if I put a number here, let's store 42. Now I can click this. And what is the state mutability of that function? It is the default non-payable. A non-payable function is able to change the state of the blockchain. So I need to pay gas for that. I cannot pay for the function. I cannot send ETH for the function, but I need to pay for the transaction. So instead of just retrieving the value that happened a while ago, now this store function is asking my MetaMask to confirm this, because I'm going to need to pay 0.00006658 in gas for sending the transaction, for it to be included in the blockchain, actually. It was quick. It is confirmed. Now retrieve is 42. If I look this transaction in the blockchain, in the block explorer, it is still indexing, but it was included in that block 59, 51, 552. If I update it here, as soon as it is indexed, as soon as it reaches the database of this application called Etherscan, it is in the blockchain already. Okay, all the nodes can agree on that, but not Etherscan application yet. Okay, Etherscan is off-chain application. Okay, a lot of people mistake that. Etherscan reads the on-chain data, but the database is stored off-chain. So this transaction was included, and here, this is the information that I have sent. This number 42, let's see in original, like this was the information that I have sent. This input data, when combined with the smart contract code inside the EVM, call data plus smart contract bytecode inside EVM equals to possibly a state change. And this is what happened. I paid some gas. The block producer received some gas, plus some math here on the 1559 thing. And we have this variable in the storage address 0, the first variable, changing from number 0 to number 42. We made a program. This has nothing to do with crypto, that has nothing to do with balances, has nothing to do with finance. We just did a small storage program to storage a number, to storage my birth date, to storage my favorite color, for storing whatever I want. This is a program, not necessarily it's pertaining to financial information on assets, on balance, whatever. Could be any kind of program that I want to code in Ethereum, any kind of program that I want to make it live forever in the blockchain. Okay. So this is it. This is the basics. This is the introduction. This technique that we used here for understanding and deploying this simple ballot.sol, this simple storage.sol smart contract, it can be expanded later for doing any kind of decentralized application that you may think of under the same basics, the same fundamentals of using Solidity for coding your bytecode, for deploying that, and for it to be hosted forever inside the blockchain as a usable, decentralized, usable program for people to interact with by sending transactions to functions. Good. This is it. I hope you had some fun there. I hope you can follow step by step. And
awesome. Matheus, thank you so much. Yeah. Well, once again, just thank you so much for showing up. For those of you that don't know, Matheus was my OG original Solidity instructor back in the day. We're going on, I think, 2 years now. So, Matheus, so grateful for you. I think the work you're doing is so important. Now, I do want to ask for folks that want to go deeper into the learning here and actually apply these things, right, to start building solutions to problems. I'm curious, like, where you would suggest people getting started.
Well, after you get these basics, these fundamentals, the next best step would be giving a try to speedrun Ethereum. That would guide you to some. It would guide you to some curated challenges with great toolings, with scaffold ETH2, by learning NFTs, using front end, using smart contracts and all, with a step-by-step guidance on how to reach there, how to complete each of those challenges, very well documented. And if you go deep enough, you can even be part of a builder guild, of the guild of builders that are contributing to the Ethereum ecosystem, right?
Shout out to Biddle Giddle. We just had a really amazing Twitter space with Austin Griffith, Kevin Jones, so many awesome people from the space. So yeah, shout out to Biddle Giddle.
Good. And when you did those initial challenges, when you're ready to build something, next step is becoming a millionaire, launching a token, right? No, just kidding. Next step is going for hackathons. Go there, find good people, find good projects to build on. Rachel, would you recommend any good hackathon or conference for people to join the next month?
Oh my God. I mean, every year, ETH Denver, you guys, come on, you can't miss ETH Denver. That is like pretty much the epicenter, I feel like, of biddlers, at least in, North America. Then we have ETH Toronto. I was actually a hackathon judge at ETH Toronto. I've gone there as a speaker, a hackathon judge. Some really great builders out of Toronto, the birthplace of Ethereum. Come on, it's amazing out there. Then we also have, I don't know, there's a lot. Like, I mean, as far as conferences goes, you just meet up with people IRL, you find your tribe, find people who are passionate about the values that align with you, and think about what problems you want to solve. And you really don't have to be an expert to get into this stuff. I've seen people who are just starting out who go to a hackathon, they find people and they learn together. We're all figuring this stuff out together, right? Some of us might be at different understanding levels, but I have seen beginners go very far just from finding the right group of people at a hackathon. I've seen it at ETH Toronto. So yeah, that's a really good one to go to.
Yeah. And we have some good examples in the ecosystem of big companies that started out as a hackathon project. Who remember CryptoKitties?
Bitcoin now was one, right?
Bitcoin. Yeah. So
yeah,
the good ones.
Smart Health. You guys might know of that one, but that was our final project during Matheus's Solidity program. We did Smart Health. You might be able to find it in a Medium article. Yeah, awesome. Well, Matheus, I would love for folks to be able to connect with you too. Where can people get connected with you? What events are you going to? What events are you excited about? I would love for people, if you're have any interest in getting involved in Solidity and going deeper into your understanding of this stuff, connect with Matheus.
Yeah, so we have a Telegram group. It's like mostly my students. We share with that here in the chat with you, Rachel. If you can showcase that.
Matheus fan group.
Yeah, it's Venture Miner Academy, V Miner Academy. That is the academy that I have inside my company. It's nothing formal. It's 100% decentralized for people to ask questions, to post about events, to share memes, to whatever. And it's a growing community for like builders that are building. There is no interest. There is no agenda, there is no whatever. It's just builders building things and cool things coming out of it.
Awesome. Well, thank you so much for sharing today. And would love to hear kind of a question that I like to leave off with our speakers is if there's any words of wisdom you'd like to leave with our listeners and viewers today, what would you share with them?
Well, for all of this work in the fundamentals, is like learn fundamentals of blockchain for you to apply cool things and stop banging your head against the wall trying to apply incompatible things with the blockchain, right? Because blockchain is there for decentralization, for empowering people, for protecting people from censorship, right? So it's super powerful, but it's also, all of those powers also restrain you for doing some other things that sometimes you want. Like, I want something super fast, I want something with low latency. So depending on where you want to go, learn those fundamentals of blockchains for you to know what the technology is going to help you with and what the technology is going to stop you to do.
Absolutely. Well, Matheus, again, thank you so much for just being such an incredible guest and such an incredible educator too. I mean, gosh, I think you've done hundreds of workshops like these at this point, thousands?
Not thousands yet, but a couple hundreds or so.
Awesome. Well, I mean, we really need more educators. I think having this foundational understanding of blockchain and Solidity is so important to be able to leverage it. Hey, Matheus, so I'm curious, why should folks prioritize going out to EdCon 2024 in Tokyo? Why should biddlers care? What kind of opportunities can they take advantage of? And what should they be most excited about?
That's a great question, Rachel. So if you're a builder, you definitely can't miss EdCon this year, because first of all, you're going to arrive for the community event. You're going to feel all the vibes. You're going to see all of the impactful people sharing about the project updates, the protocol, things that they are building. So you're going to get involved to the real source there, feeling the feelings from Tokyo itself. That should be wonderful by itself. And then if you have a cool project, or if you're cooking something cool, you should definitely apply for the Super Demo Day. You should be there watching all of those demonstrations from cool projects that are being built, that are being currently developed. You never know what kind of opportunities you can find there. You could find like partners, potential investors, job opportunities, collaborations, friends. So this is a great a great place to be in person there, to be part of it. Do not miss out the Super Demo Day at the United Nations University there. And since you are there, go for the main event. You're going to be connected with the best of the Ethereum ecosystem, of all of the partners ecosystem that are going to be present. You're going to find the best talks, the best technical content for you to be informed about new releases, new launches that are ready for developers to work on, like firsthand. Imagine being the first person to implement that cool new feature or cool new model package or whatever that was released. You're going to see all of that firsthand in the main event, connected with the builders, with DevRels from those companies, from those protocols, connected with all the fellow builders facing the same problems, reading the same documentation that you are. This kind of magical experience you can only have in person there by participating. So it's definitely a not miss. If you miss, you're not going to make it.
Awesome, Matheus. Thank you so much. I appreciate you. And yeah, thank you everyone for listening.